How does never having to fill your car with gas again sound? By simply replacing your engine with a system that runs on thorium, one of the densest materials known to man, you'll only need to refuel once a century.
So you want to know the details of this absolutely amazing thorium powered car, a car that can run for over 100 years on just 8 grams of fuel. I mean, just think about that. 8 grams of fuel, that's 1/5 the mass of a typical chocolate bar. Well, the details are, it's bullshit, and I'll tell you why. Typical car engine runs with about 200 horses under the bonnet, which clicks in at about 140 kilowatts or 0.14 megawatts. Now, according to Mashable, this power plant is going to use lasers to boil water.
Currently, the company experiments with small bits of thorium to create a laser. The beam heats water, produces steam, and powers the mini turbine, thereby producing energy.
And that's kind of a problem. You see, this is the most powerful continuous laser in the world. It's designed to shoot down missiles and satellites, and it can only put out about 1 megawatt for a minute. Further, this is not just a laser you can plug into the wall, it requires incredibly exotic fuels, notably nitrogen trifluoride and deuterium. The idea that you're going to put a laser, which doesn't even exist yet, in a car that is 1/7 of the power of a laser designed to shoot down missiles, it's a little optimistic. But there are many other reasons why this is bullshit. But before I get onto those, let me just start by chastising Mashable for not having a clue what density means.
The specialized element propelling the research is thorium. It's one of the most dense materials known in nature, so a tiny amount has the capacity to burn and emit energy for a long time.
Look, I'm just going to take a hand-sized pop bottle as a point of reference. Hand-sized pop bottle contains about 1 litre. And if that's full of water, it has about 1 kilo of water in it. That is, the density of water is about 1 kilo per litre. Or alternatively, if it was full of rock, which is about 3 times as dense, it would weigh about 3 kilos. That is, rock has a density of about 3 kilos per litre. Iron clocks in at about 7 kilos per litre. And thorium is significantly denser still at about 12 kilos per litre, but it's still not even remotely the most dense metal. I mean, things like gold and uranium are about 19 kilos per litre, and things like neptunium and plutonium are modestly denser still. But density's got nothing to do with this. Nothing at all. I mean, look, so what if it's really dense? That just means that your 8 grams has a smaller volume. Well, so what? And if it's not very dense, that just means that your 8 grams has a larger volume. So what? 8 grams of thorium contains exactly the same amount of fissile material, no matter if it's dense or if it's not dense.
By simply replacing your engine with a system that runs on thorium, one of the densest materials known to man, you'll only need to refuel once a century.
The specialized element propelling the research is thorium. It's one of the most dense materials known in nature, so a tiny amount has the capacity to burn and emit energy for a long time.
I mean, really, is this the level of the scientific literacy here? That you think that a pound of thorium weighs more than a pound of thorium feathers? And yet it crops up in story after story after story. Thorium is so dense. So what? Okay, deep breath. Let me just start by saying that I'm a big fan of nuclear power. In fact, I've worked in 3 nuclear reactors. And this is me putting my iPod in a neutron beam. That is, I think that nuclear power is really the way forward, and that it's had a real lot of negative bullshit scaremongering press. And sure, this thorium car is positive bullshit press, but it's still bullshit. And I'll tell you why. Look, there's one fairly simple principle that you've got to understand here, and that's that atoms are made up of nuclei and electrons. And when you burn fuel, you shuffle those electrons around, they find themselves in a lower energy state, and that releases energy, and you can use that energy to run your car. And per atom, that releases about electron volt type energies. However, anytime you smash up nuclei, you typically release about 1,000,000 times as much energy. That is, you release mega electron volt energies per atom. And this is why nukes are about 1,000,000 times more devastating than their regular explosive counterparts. It's also the reason why cold fusion is bullshit, in that even if you could get those particles to fragment or fuse at room temperature, that is, cold fusion, you still are generating particles with 1,000,000 or so times the energy required to break a chemical bond. That is, if anyone ever claims to have a press conference where they have a stable cold fusion reactor going in the same room, you know that they're talking shit. Because if they weren't, everyone in that room would have been killed by the radiation. To screen yourself from these high-energy particles that can break 1,000,000 or so chemical bonds, you need shielding. Now, it's the hope of these manufacturers that you're going to do that with a few pieces of thin aluminium. To which I call bullshit. Look, I've dealt with a lot of ionizing radiation, mostly in the form of things like neutrons, and we settle for some boron nitride and a couple of feet of concrete to catch stray gammas. But in reality, gammas can be stopped by electrons, and the heavier your nuclei, the more electrons you get. So basically, it scales with mass. The more mass you have, the better your X-ray screening. So your typical piece of X-ray screening looks like that, big piece of concrete. Fission-type nuclear reactions, by the very fact that they're producing particles with 1,000,000 times the energy of a chemical bond, that is, atom-smashing type energies, are always messy, messy things. There is always some penetrating, ionizing radiation that goes with these things, mostly in the form of things like gammas and neutrons. The neutrons being intrinsic, in that if you're going to get any form of stable criticality, you're going to get neutrons. And the idea you're going to stop those with a few thin sheets of aluminium is bullshit. And plus, for me, for certain, knowing that there was a 100 kilowatt nuclear reactor just behind the driver's seat, I think I'll pass on that one, thanks. And then, of course, there's the trivial point that pretty much any neutron-based reactor can be trivially repurposed to make a dirty bomb. Also, just because you have enough energy in your thorium to run your car for 100 years doesn't mean you can run your car for 100 years. Look, you can get about as much energy from fusing the hydrogen in just half a gram of water as you can get in your 8 grams of thorium. That is, your 1 litre bottle of water contains enough energy to run your car for 200,000 years. All you need is the magic of Mr. Fusion. Oh, wait, hang on 1 second. Let me add the thorium laser speak Star Trekese to convince the easily bamboozled. Hydrogen is this amazing element that powers the sun in a process called fusion. And the great news is that 2/3 of the nuclei in regular tap water are hydrogen. How cool would that be to power your car off regular tap water? So we, in this concept car, are going to use nanoparticles with specially designed enzymes to create a functional quantum density field timey-wimey thing, which will combine with an inverse tetryon pulse from the flux capacitor to catalytically fuse these nuclei and release the awesome power of the hydrogen atom, which will be able to run this car for 100 years on just 25 drops of water. Sorry, just because the energy is there in principle doesn't mean that you can use it. And saying that thorium lasers will make it happen is just not going to cut it. So you get these high energy particles out of your thorium reactor, which are typically used to make things hot, and that can then produce steam, which can then be used to drive turbines and generate electricity, and that's how your typical nuclear power station works. However, there's no way you can fit all of that in a car. And no sane person would drive around with a stable criticality giving off 0.1 megawatts around a populated city. Well, with the possible exception of Batman.
Atomic batteries to power. Turbines to speed. Ready to move out.
Thorium reactors, by their very nature, are not very throttleable. Well, they are. Just the time between when you put your foot down and when the car starts to accelerate because of the increased energy output of the thorium reactor will probably be between weeks and months. This basically means that the only way around this is you have the car constantly running at about 100 kilowatts and dumping that spare energy into the atmosphere. That would be a 10 times increase of the average energy consumption of your typical American now. Again, this is just a really bad idea. Now, in principle, you could use a radioisotope generator or a thermoelectric generator of the type used to power the Curiosity mission on Mars. So basically what you do is you get the heat generated from the decays of unstable nuclei, and then you add some cooling fins to generate a temperature gradient, which you then use to run a Peltier effect type device to generate electricity. But again, look at the details. You have about 5 kilograms of plutonium here, and it's only generating 2 kilowatts of energy. And remember, you're looking to generate 150 watts to run a relatively small car. And again, this unit is not throttleable. It generates that constant power whether you use it or whether you don't. Then comes the really stupid bit. That you're going to use this energy to drive lasers to boil water and run turbines.
Currently, the company experiments with small bits of thorium to create a laser. The beam heats water, produces steam, and powers the mini turbine, thereby producing energy.
Oh, come on. First of all, the only lasers we have powerful enough to run this run on extremely exotic chemicals, not heat. Secondly, if you did have a megawatt type laser that you could use to run a car or shoot down cruise missiles or satellites, would you really want to manufacture millions of them and put them in cars? The bottom line is that unless you're Darth Vader, lasers are simply a really shitty way of moving energy around. And that's why Star Wars failed. And I mean Star Wars failed, not Star Wars failed. And thirdly, are you serious? The more components you add to this system, the less efficient it will be. If you're using the heat of your reactor to power a laser, well, why not just use that heat to heat the water? Why add the extra component and make it less efficient? And no, you can't just power this laser off electricity, remember, because at the moment all you've got is a hot lump of material. And you want to turn that heat into something useful. And then, of course, lastly, thorium lasers don't exist, nor is there any conceivable way for them to exist. Remember, the decay events that you've got off here are giving off about 1 million times the energy of a chemical bond. Or in simple terms, if you could turn that into photons, they would be in the gamma ray region. And gamma rays would go straight through the heating chamber, straight through the car, irradiate the driver, losing a bit of energy each time along the way, and then just irradiate the environment. That is, gamma rays would be a really lousy way of heating water, because most of them would just go straight through the car and out into the environment. Put simply, yeah, this car looks cool. But it's bullshit, and even if it did exist, it would glow in the dark. Look, I've seen nuclear reactors, both inside and out, and the bits that really do glow in the dark, and I can say without hyperbole that nuclear power is the way forwards. Sure, there are hazards, but there are hazards with all power sources. And once you understand those hazards and can minimize the risks, it's like flying. Sure, there are real hazards to flying. Being up at 30,000 feet and traveling just under the speed of sound is a rather dangerous place for a human to be in. But oddly enough, once you understand all of those hazards and have minimized the risks, this is what has made flying one of the safest forms of transport. But I can hear you say, well, what about the plane crashes? What about the nuclear disasters? What about Sellafield, 3 Mile Island, Chernobyl and Fukushima? Well, what about them? 3 out of the 4 of those reactors were essentially built before man walked on the moon. And one of them was built in a simple race to develop nuclear weapons where safety was a secondary consideration. And one of them was built without a hard containment vessel. And one of them was due to an earthquake that killed 15,000 people. None of them died from irradiation from the reactor. 15,000 died as a result of the earthquake. And looked at like that, you have to simply be honest that living in an earthquake zone is a bigger hazard than living next to a nuclear reactor. Or another way of looking at it, France generates about 80% of its electricity from nuclear power and has done so for many years. And just think about how technology has changed over the last 30 years. All modern power stations are designed to fail safe. That is, just like cars and planes have gotten so much safer over the last 30 years because we understand the risks and we have the technology to design better systems, so the nuclear reactors are now much safer than ever they used to be, and they're far more elegant beasts than their clunky predecessors.